Welcome everyone. I will try to explain what recursion is and how it works. I will use Python as a language. So first of all, to understand what recursion and how it works, we have some prerequisites here. We need to understand loop, we need to understand function. We must need to have a clear idea about function. So I'm assuming that you have those knowledge. So now you want to learn more and you want to learn about the recursion. It's an amazing thing. So let's get started. So in the main function, so before the main function, I'm calling the main function. So we know how the function works. I'm calling the main function. It's the file. When I run the recursion.py file, the run will start here, so it will call the main function, and the main function will call the count with loop function. So we will enter the count with loop function, and here we have a for loop, and in this for loop all this does is it does count to 10. So let's run it. So as you see, this is just counting up to 10, counting with loop 1 2 3 4. So we have no problem with that. So now all I want to do is I want to do the same task with the help of recursion. How can I do that? So let's understand what recursion is. So in this here I am calling the function count with loop, and the function is called here. So when executing the code here, the main function in the line 46, the execution cursor goes here, and this line, if we write something print done, this line will not be executed until the execution of this thing finishes. So if we see that in action, I am placing a debugger pointer here, and let's run it. So now the main function is called and the debugger pointer is now here. So if we step into that, so now the pointer is here, it is here now. So this will so it will continue with the loop. You see here the counting with loop 1 2, it will go all the way to 10. This line is not yet been executed because you first need to finish this thing. So up to 10, 7 8 9 and 10. So now this loop finishes and the execution is print done. So we are now here. So what's the lesson here? The lesson here is the code will enter the function and it will not come back until the execution is finished. So in recursion what it does is, inside the function, so let's see one recursion example. So I have already written the function. So count with recursion. Let's clear it out. So count with recursion. What this does the same thing. So in recursion all about is it's just a function which calls itself. This is what all the recursion is. It just calls itself. So in the function calling, main is calling count with recursion, but see here, we'll come back here soon enough. See here, if we ignore this, it is calling itself count in recursion. So the function is calling itself. This is the thing in recursion. So what we want to do, so let's take one let's do one more thing. Let's define a function. So print hello, print hello, no problem with that. Let's do it, let's run it. What it will do, we all know. Print hello, hello. So this will print hello, of course, but what will happen if we call the function here? Think about it. You can pause the video and you can come back when you have your answer. Okay, let's run it now. So this just called and called and called. So hello, 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 hello. And what it happened? So it says maximum recursion depth exceeded. So that means this function called itself over and over and over and again until the memory can no longer handle. So you see that what happens here. Let's make a debugger pointer and let's run it now. You can understand it better. So this thing is called, so nothing until nothing here. So hello is printed. So this thing is calling the function itself. So what will happen? This will go back. So print hello again. This is calling the same function, print hello, 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 hello. So this will never stop. So now you have the basic understanding of how the recursion works. So let's do something useful with it. So we did counting with loop, let's do counting with recursion, the same task but with the help of recursion. So in recursion we have three parts. One is the base case. The base case means in loop we had the terminating state. For example, I want a loop to run from 1 to 10. So this is the terminating state, so until which I will run the loop. So in base case means the exactly same idea. When I will go back, so in this case, as I am trying to print from 1 to 10, I will go back when I is greater than 10. So when I will greater than 10, I will return the function. If I is not greater than 10, I will print counting with recursion I. Okay, and then I will call the recursion with I plus 1. So let's try to visualize that. So in the calling function, I'm calling with this function with 1. So 1 is here, so this thing is not true yet. So counting with recursion 1 will be print, and this call will be called with 1 plus 1 equal to 2. So we have the 2 here. So counting with recursion 2 will be print, then 3 will be called. So this thing will call itself until this condition is true. So when I will be 11, this function will return. This line will not be executed because we have returned the function here. So let's try to visualize this thing. Let's make a pointer. So at first the I will come as 1. Then if we step into that, so counting with recursion while 1 will be print, then count with recursion, so 1 plus 1 equal to 2. so we'll have the 2 here, you can see. So 2 here, this condition is not true yet, so this line will be executed. So count with recursion 2, and so this will continue until the condition is true. So 8, 9. So when it is 10, the condition is not true yet, so it will print the line, and then see the I is 11, and this time the condition is true, so the return, and this thing returns. So we have I is equal to 10 in this recursion. So see here, the I is equal to 9, so the function that called is returning to which function called itself. So 8, so this will go back to this one because this function called this function, and the execution terminates. So now we know how to count with recursion. So let's do another example here. Okay, so we all know what Fibonacci number is. Fibonacci number is this sequence. It starts with 0, then 1, and then the every next number is the summation of its previous 2 numbers. So 1, that is equal to 1 plus 0 equal to 1, then 2 is 1 plus 1, then for example 5 is 2 plus 3 equal to 5. So in this task I want to calculate the nth Fibonacci number. So if I give you 5, if I give you 4 for example, then you need to give me 0, 1, 2, 3, 4. So you need to give me 3 for example. So how can I do that with the loop? So we can assign, so this is the base case, sorry, this is for the first 2 initialized part. So n is, when n is less than 1, then we will just return the 1 because nothing to compute. When n is greater than 1, then we just initialize the first 2 elements 0 and 1, and decrement n by 1, and when n is greater than 0, then n1 becomes n2 and n2 becomes n1 plus n2, and then we just return n2. So let's try to run it. So Fibonacci loop, let's try 5. So 5 and 8, that is 21. So this is done by loop, but that's not our main focus. We try to do the same thing with recursion. So look at the code, the size of the function here. This looks much more clean and simple. This is the beauty of one of the beauty of recursion. It is simple enough, and it looks good, and it is really beautiful. So this is the base case. When n is less than or equal to 1, we just return n because that is the Fibonacci. Else it is not, then what is that? So if it is 3, then the Fibonacci is Fibonacci of n minus 1 plus Fibonacci of n minus 2. That means the previous 2 terms, we just add the previous 2 terms, and that is what we return here. So in this case we will have a graph now. So let's guess we try to get the third Fibonacci number. So to calculate the third, we must have 2, second and first. So first is 1, we know, and for the second one we get to 1 and 0. So 1 and 0 is equal to 1, so we have 1 and 1. So this thing will get 1 plus 1 equal to 2. So the third one is 2. So this is how it works. Let's try to visualize this thing. Oh, make it 4. Okay. So n is 4. N is 4 here. That condition is not true. So we have two calls here. One is with n minus 1 and one is with n minus 2. So the first one will be called, so n was 4, so we will have n equal to 3. So n equal to 3 is here. This function is not called yet. So n is equal to 3 condition is not true. We have n is equal to 3, so n minus 1, 2 will be called. Then n minus this function again, so 1 will be called. So now this is true, so 1 will be returned. So 1, so this value has 1. So now this thing returned to n is equal to 2, and now this part will be called n minus 2. So 0 will be called. So now, so 0 plus, so we have both the values here. Let's go back. So for 2 we had 1 and we had 0, so 1 plus 0 will be 1. So now the call will go back to 3. Call will go back to 3. This left hand is completed. This thing is 1, so now this hand will be called. So n is equal to 1, this thing will return. So now all the parts has completed. No, so we called with 4, so this will go back to 4, and now that this part will be called. So now n is equal to 2, then so all the parts has been completed. So now this returns and 3 is printed. I hope you get the idea. Thank you for watching.